Solar freaking roadways.
What are they?
They're solar freaking roadways.
In 2006, Scott and Julie Broussard founded a company, Solar Roadways Incorporated, with a vision of solving the global issue of finding a renewable energy source. Their idea was to replace the entire roadway network in the United States with solar panels. In 2006, the company was granted $100,000 from the Department of Transportation for Phase 1 to determine the feasibility of the project. Later on, the same department gave another $750,000 for the Phase 2 to develop and build a working solar parking lot. In 2014, Solar Roadways started a crowdfunding campaign to raise $1 million. Today, that amount has reached $2.6 million and is still gaining interest. So what is so special about these roadways?
It's technology that replaces all roadways, parking lots, sidewalks, driveways, tarmacs, bike paths, and outdoor recreation services with solar panels.
So is the logic behind the solar roadway valid? And will the cost to build and sustain these roadways be less than the amount of energy produced from the solar panels? One of the biggest problems with this project is whether the amount of energy produced by the solar roadways will be more than the cost of the entire project. This seemed to be very hard to calculate until I came across an article written by Aru Suresh from Stanford University. The estimated power generated from the road can be found in the formula power equals area multiplied by flux multiplied by cos theta multiplied by efficiency of the solar panel. The area of the all highways can be found by using the fact that there's 8.5 million miles of road lanes. From here it can be found that the average width of a lane in the US is 12 feet wide, which is approximately 3.65 meters wide. This gives the highways in the US approximately 50,000 square kilometers in area. The degree used is going to be 40 degrees latitude, as that is the approximate geological center of the US. From here it can be determined that the power generated from a high-performance solar panel, which operates at 20% efficiency, will produce 7.66 terawatts of energy. On average, when this project came into conception, the US was using approximately 3.8 gigawatt hours annually. Now, assuming the solar panels have 4 hours of good sunlight, we can find out how much electricity is harvested from this method annually. It turns out that the Solar Roadways project would harvest nearly 3 times more energy than what is needed, with 11.2 gigawatt hours being produced and only 3.8 gigawatt hours being used. Unfortunately, this is the only high point of the Solar Roadways project. Due to the fact of no room for the high-tension power lines in the roadway, it means electricity cannot be transferred over long distances. Now, because of this, the solar roads can only be used close to areas that need electricity. If we assume this, then the overall power can be worked out again, as there is approximately 15,000 square kilometers of highway close to urban areas. From here it can be found out that only 3.4 gigawatt hours is produced, which is less than the consumption of the US. This means that the proposed statement made by the company to produce 3 times as much energy as the country uses was miscalculated. This would be true if the roadway could move the energy over large distances, but due to this small oversight, it makes the solar roadways inefficient as a main energy producer. Couple this with the cost to install this and the net debt could be too great. So how much would it cost to produce, install and maintain 15,000 square kilometers of solar roadway? Well, for 1 square meter of tempered glass an inch thick, it will cost approximately $300 to $500 USD. This means that if all roadways are covered, this would cost $15 billion overall. To add to this, each square meter of solar roadway will contain 50 LEDs. So one LED around 30 cents now makes 1 square meter of glass cost $315, adding an extra $750 million onto the cost of the entire project. Overall, to add everything up from labor, cost of each piece of glass, the circuit board, the wiring, and the solar panels, the dollar signs just keep rolling on, and it's easy to see this venture going into the trillions to install, produce, and maintain. So how does this compare with the price of asphalt? Well, asphalt is one of the most used recycled products, with the majority of the product being mined with crude oil. Asphalt costs approximately $33 per square meter to be laid. This is a tenth of the cost of what a solar roadway needs to be produced, and the best news is that the road doesn't need to be repaved. Using Mohs scale of mineral hardness, it can be found that glass sits in the middle of the table. This means that glass will degrade over time and the road surface will become smoother and smoother. The reason for this would be all the roads that would be brought onto the road surface from the tyres. These rocks will scratch the surface of the glass, slowly wearing down the indents made to make the glass drivable in the wet. This means that the glass would have a very short lifespan and would need to be replaced more than what asphalt would, bringing up the overall cost of the project to maintain. Using these points, it can be seen that solar roadways is an ineffective way of obtaining electricity without using fossil fuels. While the concept behind the idea is appealing, the lack of knowledge behind the basic physics is what gave this project $2 million from crowdfunding. Some better ideas is to put solar panels on the side of a road, or to build a canopy over parking lots that have solar panels on the roof. This would be better use of the money and give better results in electricity production.